Today we're going to graph linear inequalities, which we've graphed inequalities on a number line. Now we're going to graph inequalities on a Cartesian coordinate system. And what I want to get across to you here with this problem is there's two types of inequality structures. There's a greater than less than symbol, and there's a greater than equal to or less than equal to symbol. So this one, of course, just has a greater than symbol on it. And back when we were graphing on a number line, we had the hollow circle and the filled-in circle to represent whether we're including the boundary or not, right? When you're looking at a linear inequality, the boundary is a line. And the two types of lines are a dashed line or a solid line. A dashed line is like the open circle, where the solid line is like the filled-in circle. So when I'm looking at this inequality and I see greater than, not equal to, my boundary line is going to be a dashed line. That's one of the things I'm looking for when I'm grading these problems, is whether or not you use the right type of boundary line, dashed or solid, when you're graphing. Now, as far as the boundary line is concerned, it's really simple to graph it. Hopefully by now, since we've been graphing lines since lesson 51. Pretend it's not an inequality, just pretend it's a regular linear equation. And we have a y-intercept of positive 2. That's where it crosses the y-axis. And we have a slope of negative 1, which is negative 1 over 1, which tells me every time I go down 1, I go right 1. Down 1, right 1, down 1, right 1, and so on. And all those red dots are just using that slope. Down 1 space, right 1 space, put a point. Down 1, right 1, put a point. Down 1, right 1, put a point, so on. To connect all those dots with a nice straight dashed line.
Can you go up one, left one? Or not?
You could go up one, left one also, would be the same idea. But if you connect those with a nice straight dashed line, use a straight edge please when you're graphing these on your paper, that'd be awesome. Make sure arrows are on the ends of your lines to show that it goes on forever in both directions. What that line does is it splits the plane, this XY Cartesian coordinate plane, into two regions. We'll call them region A and region B. Creative. You can call them whatever you want to. I'm going to call them A and B. Alright? Now, what I need to do is I need to shade the correct region and the region that's the truth. So, again, if I was just graphing on a number line, I'd put an open circle, I'd shade to the left or the right, whichever, right? And I'd figure that out based on the inequality. And it was pretty straightforward numerical stuff. X is greater than 9, you go to the right. X is less than 7, you go to the left, right? So that was pretty straightforward. With linear inequalities, it's not always as easy to understand which direction you're supposed to go. So the best way to do this is by picking a test point. And the only requirement for a test point is it does not lie on the line. Okay? Here's how you can pick a test point. Here's one way of doing it. That works. Oh, that's pretty good too. It's right on the 0. Alright. I was lucky. Alright? That's one way to do a test point. A better way to do a test point is this. If 0, 0 is not on the line, that's the easiest test point in the world. If it is, go with 1, 0 or 0, 1. Okay. And all the test point's going to do is I'm going to go back to my inequality right up here. And I'm going to replace, if it's the points 0, 0, what does x equal?
0.
And what does y equal?
0.
0. So I'm going to replace x with 0, and I'm going to replace y with 0 in this inequality to see what's happened. So y equals 0, x is 0, 0 plus 2 is 2, right? So what do we think about this statement, 0 greater than 2?
It's wrong.
It's false, right? We don't have to get true, we just have to know where true is. Now, if you take a look at the test point lives in region B, right? So looking, we have region A and region B. Test point lives in region B. The test point's false, which means every point in region B is going to be false, which means every point in region A is going to be true. And we want to shade towards the truth. So we just shade that area over there, and there's your graph. And again, for a linear inequality, we're looking for the correct boundary line, either a dashed line or a solid line based on the inequality. And then we have the correct region shaded, that is the truth. Always shade the truth. Test point was false, truth is over here. If test point was true, region B would be true, we would have shaded down there.